Hi, good morning. In the application of the Descartes rule of sign in finding the roots, two factors are we need to consider. The upper and the lower limits of the roots, no? And we'll show how we're going to get the upper and lower limits of its polynomials, no? So we have two problems. The first one, 3x cubed minus 5x squared minus 3x plus 4 is equal to 0. If we apply the Descartes rule of signs, we can see that the changes in sign is 1 and 2, no? So we're expecting two possible roots, positive roots for these polynomials, no? But what we're going to do is to test, no, for the lower and the upper limits, no? That is the boundary of the roots of an equation, no? At x is equal to -1, we will apply the synthetic rule, synthetic division, no? So we will copy first the numerical coefficients of this polynomial. We have here 3, -5, -3, and 4. So we divide that by -1. So we bring down 3 times -1 is -3. We add -8. And we multiply +8. We add +5. We multiply by -1 is -5. And we add again -1. So if we inspect again the change in sign, so 1, 2, and 3, no? So alternating variation in sign shows that -1 is the lower limit, no, for the roots of the equation. Now we're going to test for the upper limit. Since we expect two positive and one negative, we first begin with the x with x is equal to +1. So that same equation we divide by 1. So 3 times 1 is 3 plus -5 is -2 plus -3 is -5 plus 4 is -1. So according to the rule, this does not meet the rule, no? So at x is equal to 2, continue. We bring down 3 times 2 is 6. We add this 1 times 2 is 2. We add this -1 times 2 is -2. We add 2. So it still does not satisfy the rule, no? So at x is equal to -3, at x is equal to 3, I mean, we bring down 3 times 3 is 9, minus 5 is 4, times 3 is 12, minus 3 is 9, times 9 times 3 is 27, we add 31. So there's no variation in signs. All of these are positive, so 3 is the least integral upper limit, no? So our answer for this exercise is -3 and 1. -1 and 3, I mean. So we go to number 2. X to the p minus 32. We can write that in using the synthetic division. So x to the p, we supply all the zeros for its numerical coefficient. Minus 13. So solution for the least integral upper limit, we copy all the coefficients, no, including the supplied zeros, no. So we begin at 2. So 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 is a 0, no? So we expect that one of the roots of this by binomial is 2, no? One of the roots, positive 2. So, we try again, no? 3, as you can see, if we multiply all by this number here, all of these are positive, no? Or non-negative. Since all numbers are non-negative, 3 is the least non-negative upper limit. So, we test now for the greatest non-positive lower limit. So, since we expect only 1, most of the other roots are negative. So, we begin at 1. So, negative 1 times 1 is negative 1. Times negative 1 is positive 1. Times negative 1 is negative 1. Times negative 1 is positive 1. So, if we inspect this sign, the variation in sign, we can conclude that all numbers have alternating signs, no? So, negative 1 is the greatest non-positive lower limit. So, our answer for this exercise is similar to the exercise 1, negative 1 and negative 1 and 3 also, no? So, that's how we're going to test for the integral lower limit and the least integral upper limit, no? So, thank you for watching, and please continue to subscribe in my YouTube channel by Wilfred Tan, and click that notification bell. So, thank you, and see you again later. Bye-bye.